Hello and welcome to the 1895 podcast with me, Tom.
And me, Rob.
Rob, it feels a little while since we've done one of these. Even longer since we actually sat here in the studio doing one, because we've just checked, and the last time we hopped on the mic was while we were on the ground.
Yeah, it must be
Frankfurt.
2 weeks ago, maybe longer.
Yeah, just ahead of the event. How long ago does that feel?
That feels like a long time ago, doesn't it? And also great weather and heat there in Germany on the ground. Great recording that was. And then we've had this wonderful heat wave here in the UK.
We must have brought the heat back with us.
Yeah, we must have, yeah. So, and some very hot topics in focus as well.
Absolutely. And we did promise it in that previous episode, but we're going to delve into the event in this episode. And I don't think we'll be able to cover it all in just a single episode. So we might have to wheel this out in a few different parts.
Yeah, I think so. I think this might be 3 episodes potentially, because there's so much to dive into. I think we need to look at the whole semiconductor, AI and electronics side of things. I think then we need to dive into the whole specialty gases side, which obviously the event was about. And then there's a distinct episode just around helium and what do we know, what's the update, and of course there's been a bit in the news recently. So yeah, we'll try and do that, I think.
Yeah, I think so. So let's start off with that first topic that you've raised there, and that's actually how we started the event in our session 1, where we discussed chips with everything. 3 fantastic speakers, a couple of returning speakers in that session. We had Lita Shon-Roy of the gasworld advisory board as well, and there's so many different parts and figures and facts to dissect from this session.
There are, and I think, for me, I'm not sure about you, Tom, but across the kind of 2.5 days of the event, one of the things that came through loud and clear was the message of trust. That was a kind of 3-pronged thing that I've got in my notes, in my notebook from the event, was trust in reliability of supply, trust in expertise and capabilities, and trust in the measurement and the monitoring and the molecules. So 3 distinct areas of trust there that are key to everything. And of course, when we're talking about chips with everything, the rise of microchips, devices, AI, and everything that we rely upon today, that relies upon a trust in specialty gases, a trust in the molecule development and that collaboration between sectors.
And I should say, before we got into that first session, we actually had that opening keynote from Bernd Eulitz, the outgoing CEO of Messe, and he touched on a similar note as well, especially surrounding the chips with everything angle.
Yeah, he did. Yeah, and look, you can't do it without the specialty gases. We've said that so many times before. So, good to get that sense of partnership, that reliability in supply chains, and obviously we've talked so much about reliability of supply chains as a whole in the last kind of 3 or 4 months, haven't we?
Yeah, well, look, I think that the people are tuning into this episode to hear those expert opinions and those takes from Lita Shon-Roy. So let's take a listen.
Let's take a look at 5 key factors driving the semiconductor industry. The first one is the economy, and it is relatively healthy, although, as we have seen, it is always much smaller in growth than the overall semiconductor industry, which this year is hugely growing, as well as it was last year. We'll talk more about that. Chip value content within each electrical system has increased year over year, and we are now seeing that most electrical systems, their value of semiconductor content is now about 35%. And in automobiles, it's also creeping up there, upward to 40%. The third key point is, of course, the huge trend that's been driving chip revenues over the past couple of years has been AI and data center build-outs. This is overshadowing other application areas. However, the market for automotive and 5G and mobile devices they are all continuing to grow, but at a much more normal pace, while AI-related chips are dominating the revenue. And we'll take a finer look at what's going on there too. The fifth key point is that in terms of materials, here growth is also quite healthy from a revenue standpoint, and and we are very happy to see this year is looking very good compared to the last 2 years. And I'll give you more data on that in just a minute. So in terms of semiconductor revenue growth, our keynoter was kind enough to launch his slide and what's going on there. This is a TechInsights slide showing huge growth year over year from 25 to 26. We see a 70% increase this year from last year in revenues. This is, of course, primarily due to AI. 5-year growth projected is 10% year over year through 2030. And we do expect to see a little bit of a correction cycle downward. But the main point here is that the market could slow. There are some concerns about data center build-outs, that people don't want them in their backyard, or it could escalate further. So you never know how fast we might get to 2 trillion, while we'll get to 1 trillion this year. Also interesting to note is that optical power discrete and sensor devices, OSD, and analog devices, as shown here, is small but growing, and while prices of AI chips will normalize over time, the contribution in revenues of those chips to the overall market will grow, showing here 14%. The analog and OSD chips is about 14% of total contribution, moving to 19% by 2030. And to support all this growth is, of course, the investment that's going in. This is $250 billion per year that we see happening over the next 5 years, a combination of government stimulus as well as investment from the chip making and fabs themselves. Of course, advanced logic and memory are showing the largest investments, as you can see here on your left side. Those are the chips that largely support AI. And in terms of location, no surprise, Korea, Taiwan, and the US are leading here, especially Korea and Taiwan, with Europe representing less than 3% of the total. And although small, it is important, and I'll talk more about that in just a bit. With regard to materials, I just want to show you our roll-up of materials that we track. Each of these segments represents multiple subsegments. Process materials, for example, represent at least 8 categories, one of those categories being gases. And of course, gases, the largest contributors in the gas area are precursors, dielectric precursor gases, metal precursor gases, as well as etching gases, air gases, and rare gases. These gases represent about 10% of overall process revenues. So while we do see materials receiving a healthy boost from AI demand, and we are forecasting 8% growth this year and a 5.4% compound annual growth rate. So it's all good news. This does include what we see as a natural cycle down in about 2028, although we are seeing that, well, there's quite a lack of NAND memory capacity. If investment should increase and build more NAND capacity, we could have a bump up of 6.4% by 2030. So the result of the semiconductor industry's growth is that the materials market that is expected to go from $70 billion in 2025 to beyond $90 billion by 2030. We're looking at a healthy future for materials market segments. Now let's look at Europe's semiconductor market and outlook. In terms of chip expansions and investments in Europe, here are the leading ones that have been announced, happening since 2025 and going into the future. Global Foundries expansion in Dresden is underway. Their fab, with 1.6 billion euros worth of investment, is expected to start up in 2028. Then there is the Infineon expansion, also in Dresden, expected to start up sometime this year. And ST and X-Fab are also expanding, but the largest investment that will push up Europe's participation in leading edge, of course, is TSMC's joint venture with Infineon, Bosch, and NXP. This is leading the way with $10 billion of euro investment, scheduled to start up in 2028 with production in 2029. This is a very significant increase in leading edge for Europe. Other noteworthy activity going on, Intel is pushing up production as much as possible. They have publicly stated that they will not create or generate more greenfield facilities until they actually have orders on the books, but they are taking existing facilities and pushing production up 10%, 20% where they can. So that is not included in our estimates, but some of you here may be benefiting from some of that activity. Very exciting, especially Intel and Leaslip. In terms of chip manufacturing in Europe, which of course does drive overall gas demand too, we see, here's the, from Jonas, he provided me the picture of the Volvo 2026 Volvo EX60, which is built around two key AI processors, a 5 nanometer class Qualcomm Snapdragon cockpit silicon on chip for the main console. It's got an NVIDIA AI chips, which act for the vehicle's central AI to control autonomous driving and other functions within the vehicle. These advanced types of features are also being incorporated into VW, Mercedes, BMW, and other automotives. So these new models will definitely allow for more participation here in Europe, given that they do demand AI chips as well. Revenues from chip manufacturing in Europe totaled about $16 billion, as shown here in 2025, and is expected to grow 9% per year to total nearly $25 billion by 2030. The growth will be primarily driven by automotive. However, markets that were depressed last year are also contributing to this uplift, and those include 5G and mobile devices, for example. And in terms of the types of devices that are driving this growth, this is a demand chart or consumption chart. So it's just sort of a hint at what type of manufacturing has been focused here on Europe. In Europe, the lower row here indicates that 12% of the spend of worldwide chips is 12% of worldwide chips is Europe's spend for analog devices, 15% for sensors, 16% for discrete. So it's no surprise that that is what Europe has been focused on over the years to support the automotive industry.
And that was Lita Shon-Roy of TechInsights there. A great way to, I guess, set the scene and look at that semiconductor market in Europe ahead of the event and ahead of those 2 days of discussion we were about to have.
Yeah, and what I particularly like from Lita is we get an update on Europe's chip expansions. The likes of Global Foundries, Infineon, ST Micro, X-Fab, ESMC. She gives us the update on where those plants are at, where those investments are at. A lot, mostly around France and Germany there, wasn't there? With a couple of other outliers in there as well. And I thought it was quite good. Lita said, look, this sector is in high growth. I think most people that follow it would know that. AI could, she said it could slow. Some of the growth rates could slow, but it could also escalate rapidly, particularly with this whole advent of AI driving everything. And that leads us nicely into Eric, doesn't it?
Yeah, fantastic segue. Almost like you set out the agenda
in that
way for a reason. We're getting at Eric Balossier, also of TechInsights presentation here. And he discussed just how AI is driving chip development through to 2030. I spoke with Eric on the ground following his presentation as well. You can take a listen or watch that on the gasworld website. But Eric was very bullish in his, I guess, how he expects AI to grow, and gave some huge figures there as well.
Yeah, should we give a precursor or just dive into Eric?
I think let's dive into it and allow the audience to react how they should. So let's take a listen to Eric.
So a few months ago, we had rounds of internal meetings at TechInsights to acknowledge that the $1 trillion mark would be reached in 2026. And we were amongst the first companies to claim that would happen, and that was uncomfortable. Today, as crazy as it sounds, and as Lita told you, we are discussing the $2 trillion mark. Much, much faster than we expected. So here as long-term forecast for the semiconductor annual sales. You can see the acceleration in 25, 26. So this is the AI wave. This is where we can touch the 2 trillion. There will likely be a correction. There are always corrections in the semiconductor industry. But that being said, the long-term trend is very strong. It's high single-digit CAGR. And we are very confident that the market is on a very strong path for the next few years. The boom in AI in 26 and 27 is primarily ASP-driven and primarily memory-driven. Memory sales are up something like 200%, and DRAM is now a $500 billion market, which is incredible when you've been in the industry for some time. So as a foundation for this presentation, I would like you to keep in mind that AI is the catalyst for semiconductor expansion and has already completely transformed the industry. Let's take a closer look at the current cycle. So TechInsights, as Lita introduced you, has a unique ability to create model input for the entire supply chain. So electronics, semiconductor, capital equipment, and material markets. And this multifaceted approach is tricky to synthesize. So we introduced funky ways of representing how the market is doing. So let me introduce you the Global Chip Making Climate Trend Index. And there is global warming. That's something we see also in the semiconductor industry. So a normal temperature, kind of an average, would be around 70 Fahrenheit, so 22 Celsius. So when the temperature is high, order increases and delivery become the primary concern, and the other way around. When the temperature goes down, the book-to-bill is below 1, and demand is the challenge. So as you can see, the semiconductor industry is already enjoying a hot summer. And I added a few selected end demand markets, which are compute, memory, and advanced packaging, that are pretty much off the chart. And this is materializing a very clear demand for AI and a very clear demand for chip-making equipment and manufacturing. And indeed, the SoC DRAM flywheel is the dual engine for semiconductor growth. So SoC for system on chips. So here you can see the market value for the chips. The big orange bar is compute, and it is dwarfing pretty much everything. And it is mostly driven by data center AI. As a direct result, the memory market is doing something it has never done. I would like to pause here for a second. This chart shows quarterly revenue of the memory producers, so the main Samsung, SK, Micron, and others. It goes back to 2005, and it is at scale. And so you see that history has nothing to do with what's happening now. And it is a fast change. This is a new world for the semiconductor industry. And we will not go back. This is a new normal. Good news is that AI is also pervading all applications. It's not only data center. It goes into edge AI, so PC, phones, wearables, and also the physical AI. That would be automotive, as you've seen with the Volvo car, and robots. And that's an emerging frontier, probably the best opportunity for Europe because of the strength of the industry in that domain. So obviously, AI has completely transformed the semiconductor market, pushing the demand for more fabs, more innovation, and more end demand, basically, new applications and new markets. But it also, and probably even more so, reshape the technology and the innovation in the semiconductor market. So here, introducing on a single slide, which is a bit busy, but I get through each and every theme later on, the different key technologies that AI is driving. So obviously, we have already touched advanced packaging. It is instrumental in the AI transition. It's expanding the concept of system on chip to new heights, literally, and offering opportunities for players in the supply chain and in the XPU attach space. So it's not only the accelerator. Europe has a key opportunity here for the equipment makers, but also to leverage the amortized fabs, the materials, and the mixed signal expertise to participate in this transition. And potentially go beyond with disruptive memory and compute concept, as you have seen in the introductory video for those that were here early. 2 nanometer is a key moment in the industry. Until now, TSMC has almost a monopoly for advanced manufacturing and AI. We think that competition will be much more intense at 2 nanometer and below with Samsung, Intel, and Rapidus in Japan. So offering much more opportunities beyond TSMC. As Lita introduced you, Europe has a unique position to enable those technology. Even though we don't have advanced foundries, without the European machines, you can't do those beautiful gate-all-around stacked transistors. And the dots you can see here are atoms. And that's expanding on Bernd's introduction. That's the level of precision and quality we are looking now. And that's something quite unique TechInsights is renowned for, which is the reverse engineering of the process. And yeah, quality, precision are not optional. And this is the co-packaged optics. So that's a different kind of advanced packaging, but that's a key opportunity for Europe, as I will come back. And all those technologies are introduced to deliver more compute per watt. And breakthrough in power management also create major opportunities for European companies. So Moore's law just turned 60 and is still very healthy, although its meaning has evolved. Interestingly, Jensen's law, which posits that GPU performance accelerate much faster than Moore's law, has not replaced it, but complemented it. So we see an acceleration of the design start at 2 nanometer and below, and a rush for the manufacturing of 3 and 2 nanometer generations. So again, this is at scale. So these are all the technologies back to 2015, and these are just 3 and 2 nanometer. This is in value, and you see the effect of the ASP of memory here. Two transformations drive the Moore's law, a change in economics. Moore's law is not used to transfer added value to customers, which is what the semiconductor has been doing for the last 40 years, basically. It's now used to achieve the highest, best performance at a premium. And the chiplet integration plays a role also because you can use those advanced technology only for compute, and you don't need to develop a full-featured platform. Typically, I/Os, interfaces, analog things that do not scale well can be done in older, more mature technology. So again, here you see the phase change in the industry. We are in a new world. But Moore's law is not enough. You need more than Moore. And so this is the same in chart that Lita showed, but a bit bigger. An AI chip is not a processor. This is a full system that embeds multiple memories, so typically the HBM, different chiplets, compute, network, whatever. And you can't really do AI without this disintegration because core computing is typically too big. Either it is reticle size or even bigger. And AI makes the best use of high bandwidth memory and networking, and you need to bring as close as possible the chips to maintain the bandwidth. There are additional benefits to heterogeneous integration, such as IP reuse and technology platform optimization. And the advanced packaging approach gets even more interesting when you add optical communication to it. So the era of copper is coming to an end for the high-speed communication as AI data center move in the terabit era. So as you can see, beside the very short distance, copper cannot keep up. Retimer has expanded the window, but doesn't change the problem. So you have to go optical, whatever you do, and especially anytime you exit the rack. And co-packaged optics, so CPO, and photonics are a strategic opportunity for Europe. Europe has largely missed out the GPU-driven layer of the AI boom. NVIDIA and the major hyperscalers are all US or Asia-based. But co-packaged optics and silicon photonics represent a new layer where Europe holds competitive advantages. Europe has a world-class photonics research infrastructure that predates the current AI wave coming from the telecom era. And Europe has the substrate and materials experience to be successful here. Yet, it's moving very fast. So let's capture the opportunity now, otherwise others will.
So there you have it, Tom. An AI chip market already pushing the semi sector beyond a $1 trillion market in 2026. And you heard it here first, a $2 trillion semi market in the next couple of years, ahead to 2030, say, at most, I guess.
It's huge. And he did say that the bubble will kind of burst eventually, or there will be a grounding and a leveling of these numbers, but still to reach those figures just gives an idea of the opportunity there, especially for our industry.
Yeah, I mean, he's very clear, isn't he? AI is redefining markets. I think there's a direct quote that Eric said, for semiconductors, AI is a tidal wave raising the market. I mean, yeah, we all know about that whole AI movement. We're all using it, I expect, in different ways today. But it's when you put it into numbers like that, it just goes to show why everyone's talking about it, why it's so important, why we need more conversation around it in these semiconductor markets and with specialty gases. Just the other thing I would, some of those pointers from Eric and the AI chip development through to 2030. Quite interesting to hear him use that analogy. I don't know if you remember. The concept of global warming in the semiconductor sector. He said the temperature is rising and we're currently in the midst of a hot summer. As you said, as you said, we could go into that winter at some point. But it's really interesting, the strong growth, the automotive manufacturing market as well, particularly in Europe. He showed us some of those vehicles, didn't he? I think Volvo got a mention. Yeah, and the huge technologies going into vehicles these days, all with AI, all with chips. And then one thing I made in my notes is how he described that AI is redefining what the integrated circuit is and the architecture of it. And he's talking about the layers, the layers of the chip, basically. And he was using that to explain why Moore's law, which has been underpinned, it's the theory that has underpinned kind of semiconductor development for 50 years or more. A lot of people saying in more recent times that it was not applicable anymore, that theory, but actually Eric used AI to say how Moore's law is still relevant today. It's simply evolved in meaning, and now we're heading into an era of more than Moore. So some really key insights there, and a lot that the specialty gases business needs to sit up and listen to, I think.
And I have no doubt that this is a topic that we're going to be discussing for years and years to come. And when the Specialty Gas Summit returns, I'm sure that will return to the agenda just because of how big this is really going to be.
So Tom, I think it'd be nice to come to, just for a final section here, because this works really well. You mentioned our opening keynote, Bernd Eulitz of Mesa, outgoing CEO of Mesa, which was great to get his candid thoughts on stage. And there's a good link here, isn't there, between the two talks we've heard already from Lita and Eric of TechInsights around chips, and then actually the next episode where we're going to focus on specialty gases, because Bernd Eulitz kind of brought that together. Yeah,
it's a lovely bridge between this episode and what's going to be the next one. And it's great to get Bernd Eulitz on stage, the outgoing Mesa CEO. So great to hear from him, and let's bring that to our listeners now.
Yes, we might have challenges, as we always have, up and down with supply, but there's fantastic opportunities ahead of us. There's fantastic growth, and I'll talk about that. And it all nicely feeds into higher quality, higher pure gases, more sophisticated mixtures, and PPBs or 0-point-something PPBs that our customers are demanding. So I believe there's a fantastic development ahead. So let's see. On one hand, you hear supply shortage trouble. You hear, for example, that the first MRIs do not need helium anymore. You hear shifts in some supplies. Well, let me be very, very positive about this. The existing MRIs will get relocated to other places. They will still need helium. And there's new helium demands coming up step by step as we look into the industry. Just one short note to the space industry. The launches of the space industry is increasing at a speed that is phenomenal. Every rocket launch needs helium for basically two aspects. They need helium to pressurize the liquid oxygen tank, the liquid hydrogen or jet fuel or liquid methane tank, but they also need helium to purge what they call the runway, the place where all the cables come from the computers to the rocket engines to steer the engine. So a rocket launch roughly needs 0.8 ISO containers helium. Then you see now with the chip industry moving to ever higher speed, the connections between these AI chips with normal cables is not fast enough, so they're moving to optical connections, and these fiber optics need helium in their production. So there's another area of growth coming ahead. Beautiful developments everywhere. So I've touched on space. Space needs oxygen for launching a rocket. Yeah, that's normal oxygen. They need the helium for their launches. But they transport a lot of satellites. And every satellite needs usually xenon for ionic drives. SpaceX, for example, I think has roughly 9,000 satellites in orbit. They want to go to 30,000. Then when you do the math with all the other companies, we're looking at 100,000 satellites in orbit soon. Every single one of those needs xenon. Xenon will be short. You suggested that might happen. I would say that is a likelihood. But xenon also is one of the gases that go into the chip industry. So there's beautiful growth coming from space. And all these products usually need very, very high purity. Even more so when we move into the area of chip manufacturing. On one hand, the normal, if you will, the basic chip industry is coming back now more and more. There's these swings in chip industry that are normal, and you see this industry coming back. And then on top, the need for AI chips is driving the chip industry very, very strongly. For quite some time, it sounded like only TSMC is the company benefiting, but now it's the broad industry. It's the guys who make the high bandwidth memory, HBM. That's Micron, that's Samsung, that's SK Hynix. They're all growing, but that's even other companies that you don't have on the radar, like SanDisk and the like. So there's a lot of growth in the industry. And the interesting thing is that they all move to ever more precise and smaller bandwidth, smaller chips, smaller nanometer chips. I think TSMC has announced that they are now starting to produce 2 nanometers. Now let's go back to the basic supply. So every chip manufacturing site needs a lot of nitrogen. Why? Well, to keep the clean room clean, to keep the production sites clean, to keep everything dry and the like. Historically, they would go for 7.0 quality. 7.0 basically means 99.99999 here, this many nines. The new discussions we have is 9.0 as a standard. Yeah? So basically we're going up 2 decades in quality. Very interesting. This is going to be the new norm for standard nitrogen. It's going to be the new norm for standard argon going forward. So you see the requirements of the industry increasing ever more. And these are large air separation units. Yeah? We talk about 50 to 100,000 cubic meters an hour. We're talking about very large units. So even for the standard products, the quality demand is increasing step by step significantly. That same cascades obviously into all the electronic specialty gases, and this is maybe more what this Congress is about. The demands go ever higher in quality and purity, whether it's the pure gases, it's the mixtures. The definition the customers give you are so precise that they want 1 molecule per million or billion of other molecules, and please not this molecule and not this one. And they want you to deliver this exactly and precise, guaranteed and reliable. So this is the development that we see everywhere. It's a beautiful growth, and it's a lot of innovation, because to make these molecules, you look at your filling process, your production process, your cleaning process, but also you look at your analytics process. What do you need, gas chromatographs or other tools, to be able to measure this quality and then guarantee it? So there's a beautiful development in this direction. To help you get a feeling for what is happening, I tend to make this comparison. For every 10 to 15 billion dollars a global chip company invests into a chip fab, a gas company will invest roughly 1 billion into gas manufacturing. Rough rule of thumb. TSMC is building sites, I think 9 sites right now. They've announced to invest 165 billion. Micron has announced 200 billion. Obviously, these are usually investments over 10 years. And you see all the other guys investing. Samsung, SK Hynix, everyone is investing heavily into the chip industry, heavily into the growth. I think Korea alone, as from the government side, has announced to support $470 billion investment into the chip industry. So keep in mind, 10 to 15 billion into chip fabs means 1 billion into gases. So there's a lot of growth ahead, and that is thrilling. I talk a lot about, obviously, space and AI chip industry because it's a large growth driver. But we tend to forget, and maybe in this room, in this theme, it's also important to keep an eye on the healthcare area. While we all know oxygen for medical treatment, there's quite a few things also being discussed around therapeutic gases, the value of xenon in treatment, and the value of other gases, which again nicely feeds into the specialty gas area. So I don't want to forget that, but the large growth and the driver, which will, I think, change part of what we do in our industry, is obviously space and the chip industry. Now, what do you need to be successful? Well, it's proximity to our customers, to your customers. Yeah? And I think this is very important, and you see that even more in the chip industry and also in the space industry. You build trust, and you build trust over time through reliability. And especially when things go wrong and you act fast, help solve it, you build more trust. So trust is the key in relationships. What you deliver to these companies is of highest purity, of highest quality. And what is super important to these companies, let's take a large chip manufacturer. The quality is so important that you shall not fail anytime, which means you need to build the trust that your reliability is there, that your analytics are there. You need to send your analytical documents even before your product arrives at the customer site if you look at very dedicated special electronic gases. You need to be reliable. Trust is about reliability. Right now, helium is the big topic people talk about. Trust is super important. And once you manage that aspect, once you manage this reliability, you will become the key supplier of your customer. And that's something we look at very intensively all the time. It's about our people being very local, nimble, able to react basically on their own. Yeah? Jump the car on Sunday if there's a problem at the customer. Reliable supply. Do not ever depend on one single source. 2024, we bought the strategic helium reserve in the United States as there was a law to sell it. The former BLM, which is now Messer Helium Cliffside. But we only source less than half of our helium from this site, and we keep the rest of the supply very global because we want to ensure that we can supply our customers whatever happens. Super important in these moments because this is when you build trust, when the customer sees that you really have done your job. Reliability is extremely important.
Bernd Eulitz of Messer. Rob, we were speaking after the event, and I know that was one of your favourite presentations, one of your favourite moments to be on stage there with the Messer CEO.
It was. I think it's always an honour and a privilege to have a CEO of one of the big kind of tier one gas companies on your stage, or a CEO of any company, to be fair. But I think being an outgoing CEO as well, he had an added air of freedom, perhaps. It wasn't like he went and said a load of things on stage that you couldn't normally get away with, but he just felt a little bit freer, liberated, and gave some honest assessments. But actually, for me, some of the sentiments were in the things he needed to convey in that presentation. And we talked a lot about how gases are needed for chips. I mean, he said, I'm not sure if we heard it there, but he said that for every 10 to 15 billion euros, for example, that you might invest in a new semiconductor fab, you need sort of 1 billion euros in a gas plant as well to get the specialty gases provision. And he also was very strong on that sense of trust that I mentioned at the start of the episode, and you build trust through reliability. So for a supplier like Messer, for the others across the region, across the world, they need to build trust for those end users through the reliability of supply. So that was really important. And he told us, didn't he, how Mesa is doing that, how it's got programs in place, how Mesa actually bought the Federal Helium Reserve essentially in the US to shore up that helium side of things as well. So some really key messages coming through.
Yeah, fantastic presentation, and big thanks to Mesa for being our platinum sponsor of the event as well. I think that's enough from us today. We said we're going to have to split this into several different episodes. We've been recording now for a little while. Time to digest that, and then we'll be back next time to get into more of the event, and so many more topics yet to come. We've got rare gases through to 2030. We've got Nippon Sanso on supporting the customer from lab to fab, and so much more to get into. So please do like, follow, and share the 1895 podcast, and we'll be back again next time.